Okay, got one of these pressure pump and with one of these electronic pressure controllers on it. So basically these, as soon as you open a tap or something and the pressure drops, they'll actually start pumping. And as soon as you close the tap again, it'll repressurise the system and then stop. Well, that's what they're meant to do. This one doesn't actually run at all. And it's got one of these standard sort of blue controllers, and one thing I should say at the beginning is you can actually buy a complete one of these for about $35 on eBay. I think it's 35 plus post, so about 40 or something. And even the little circuit boards in these, I think they've got them maybe from China with a surface mount chip instead of this old chip, and those are only around $20 or something, I think. So they're not really the most economical thing to repair, but I thought I'd actually have a look at one. This was just one from a junk shop, and I thought I'd actually have a look and see how they actually work and what might go wrong with them, since these are quite a common item now for anyone who's on tank water or the like and doesn't have a gravity fed system. You basically use these to, every time you open a tap in the house, this will pump water and give you pressure. We've actually got one here, but we use off dam water, so every time you open a garden tap, it pumps it from a dam that's a bit lower than where the garden taps are. And yeah, that's been working for years, that one, but this is just, looks like a bit of a cheaper one. I don't know, orange pump, never heard of the brand before. Not sure where it's made or anything like that, probably doesn't even say, probably just a sort of cheap generic one. These controllers seem to be fairly generic. Now they have on the back of them, I've actually pulled this to bits to have a look at it already. This piece sticking out the back, which is the pressure sensor, the mechanical side of it, so you've got the outlet of the pump. Goes through this body, and that goes off to your line to your house or wherever, garden, taps or whatever. And obviously got an inlet here as well that goes off to your water supply. It could be a tank or a dam, something like that. And what these things actually have is this, there's actually a diaphragm here. You can sort of hear it going in and out. There's a bit of an air outlet in the end there. And this rubber diaphragm thing, I don't know, haven't actually pulled this out, or I don't know if there's a big spring behind it. That's not surprising. And the rubber diaphragm, obviously if this diaphragm gets too stiff or gets a hole in it or something, that'll fail. Now the other thing this has is this arm bit that sticks so to keep the water completely separate. This is in the water, so it's basically between the pump and the line to your house or taps. And that's screwed on there, whereas the rest of this case, obviously with 240 volts and electronics in it, is all completely sealed. But the central part of this other piece comes up this blue piece here, and this actually has magnets in it. I think it's actually got more than one. But if I get a screw, and there's one there, maybe it just goes for a certain distance, but there is at least a magnet there. That must be about it. And so that's what actually comes up inside this other plastic bit, and that's actually used to trigger a couple of reed switches. So I guess when there's no pressure on the line, like you open a tap or something, this diaphragm will push out to a sprung position, I guess. The spring will push it out, and this thing will go in as deep as it can into the actual blue piece and towards the electronics, towards that front panel bit. It'll go, so it's in through that way, and it'll go as far towards this front bit as it can. Once the pressure rises, that'll slowly push this back until the pressure will just hold it away. So I don't think it moves an awful lot. Let's have a look. What can I put it up against, I guess, but this is not even 10 mils by the look of it, which could be a problem. Maybe up to 10 mils, depends how high pressure the water gets, I guess. You can probably get 10 to 20 mils out of it. So it's quite possible that this could actually mechanically change over time, but that doesn't seem to be the problem in this one. It seems to be the electronic controller. At first I didn't think this was even running, so I actually tested it. You've got this, there's a diode, this capacitor here basically likely drops your AC down from 240 volts. We've got a couple of these varistas, I think, just like surge protectors. At least I assume that's what they are, but most likely, yeah, they go between active and neutral. You can see one of them's across there. So if there's any lightning or power surges or anything, these should take it. Looks like they're both basically wired in parallel, but one's hooked to the, looks like they're both hooked to neutral, and one to the active on the output of the relay. So anything coming up that line from the actual pump motor, which I think that's one of the pump motor, isn't it? Yes, that goes to the pump. So that's the output. Switch via the relay. Well, of course it is, because I saw the relay there. And that's your power in. So there's a protection on both lines. Mainly they'd probably only ever get used if there's either a lightning strike or someone knocks high voltage power lines onto the normal ones. So you've got to think that is probably just dropping the 240 volts down. You've got a rectifier diode, you've got a filter capacitor there, and I think I was getting around 7 or 8 volts across that. But this one, the LEDs are so dim you can't even see them. At least CMOS chips I think work from about 5 volts up to 15, 16 volts. So I could be wrong, it's somewhere in that range. Just a standard CMOS chip. So I think 8 volts is probably okay, but it's possible that something's wrong, either that cap's change value or the electro. I think if I hook this up, I was actually doing it in daylight and you couldn't even see it. Yeah, it is kind of visible now. Obviously I don't want to touch any parts of this board because some of it's technically not isolated from the power. But you can see that does come on, only just. In daylight it was virtually invisible. So that's the, we've got a power on LED, pump on, so that whenever that relay switches, or it should switch at the same time as that comes on, and a failure light, which I think basically means there's no water or something. And we've got obviously a relay here which you put 24 volts into it by the look of it. Interesting, it's 24 volts, so it makes me think that rail should be higher, though I didn't check the actual voltage going into that. There may be a second rectifier or something here. What's that capacitor rated at? 50 volts. So maybe it is a problem with not enough voltage getting in. That's a definite possibility. I don't think a CMOS chip will run up to that voltage, though it could be that the voltage has dropped to that somewhere. I think from memory whatever 8 volts or whatever it was going to the chip. So I might have to check that. Also what I found, there's these little glass bits here, one on a blue bit there, one on the back here, and a little blue plastic holder, and they're reed switches. And what I found is if I put that magnet, this board sits in with that blue piece sticking through, so this magnet comes basically through here, but obviously with a plastic surround around it. I found it will trigger this close switch, but the one further away, I think even when I put it right up to it, it doesn't seem to trigger, so that could be that the reed switch is faulty. What I did find is if I put a jumper lead across both of these reed switches, you get your fault LED on. And like I say, when I do connect across that, well, I can actually demonstrate it, I guess, it does seem to run the pump. So that we would assume there's enough voltage to run everything if that's the case. I think let's see. So these switches are normally open, I think. Yeah, it's open and open. And if we bring a magnet in close contact, we should be able to get it to close like that. But with the other one, it doesn't want to seem to do it. Now, I don't know if these are orientated in different ways or anything, these switches. That could have some effect on when the magnet affects them. If I go really close, it's kind of... See, that doesn't seem right to me. It's like intermittently working. Now if we get really close, but down there it certainly doesn't do anything. I don't think there's any other magnets in here that can affect it, although there is. Where does it sit? It actually sits... now maybe we're onto something different here. There is a valve in here. I wonder if that's got another separate magnet in it. Oh, there is two, possibly. It looks like a bar magnet in there. That might explain a bit more of... So we've got some sort of valve here, so the pump, that's like a foot valve, so the water doesn't go back down the pump. So if this thing's full up and pressurised, it can't push back down through the pump. And this is another similar, I just thought it was a foot valve. The second one, but looking at this, I can't really move it easily. There is possibly a little bar magnet in there, so when that rises up, I guess that means water's flowing. So that would suggest that the bottom reed switch is triggered by this. But is it triggered when it's... Because yeah, that'd push in. I guess when that magnet goes back because of enough pressure, that would be the one to turn the unit off. Would make the most sense. Maybe not. Maybe that one's triggered when it's in the rest position. Take that out. That's kind of the opposite from what you would think, because that bypassing that one should get the pump to run. But I guess it depends on the state of this other one too. But then you'd think that's when you'd think you'd get your fault mode. So that is now triggered. And what I need to do is try and move this other bit while I stay connected to that one. Which is going to be a difficult job. I might have to solder some links on here or something. Yeah, when I push that up high enough, so that's water flowing, I guess. So we've got the green LED. Pressing that does nothing. I could have sworn closing that before. Oh, maybe you need two. That closed. Get in there. Oh, now we've got a fault mode. Yeah, so you need that one open. Oh, maybe it was the other one. I could have sworn it was the back one that I... So if we could force that up... The red LED is actually visible now, so in the daylight they're hopeless. I wonder if I can jam something in there to keep that up. Yeah, if I put something under that top bit. I'm going to hold it in place, so I'll hold it open like that. We're not getting a fault light now, but we're still not getting the pump running. Drop that, we get the fault light. You know, that should run in that state. It'd be nice if I could get the silly thing in there. So that should run until... That really doesn't make a lot of sense. Because this normally would not be open, it would be closed. So it's almost like this is doing the opposite of what it should. Yeah, now we don't get any fault light, but we don't get any pump switching. So I guess the best thing will be to unsolder this capacitor and test it. At least if we know what voltage should be in this thing, that's a good start. There we go. It's 11 ohm ESR, 268 nanofarads. Seems a bit low for a 1 microfarad capacitor. So that may be our problem, that we've got low voltage feeding this thing. Like I say, I think 247's in parallel should give us what we want. Just for test purposes. Well, I can soon do it on the tester, I guess. If in doubt. Let's remove that and put one in here. Put one right in there, put the other one across it. There you go, 949.5 nanofarads. So that's much closer to what our 1 microfarad. So I think we can be pretty certain that'll work better. Oops, missed. So put one directly on the board. I'll just drag the other one across it and we'll see what this thing does. At least we'll know what voltage should be in here. And whether this thing wants to work or not. So it could just be that this is acting strangely because the voltage is too low. Possible also that yellow LED only comes on when the relay is closed rather than from whatever's commanding the relay. I'll just poke that back in there and it will either blow up or it might work. Bingo. So that's now running. I guess I don't want this pump running. So which one's the pump? That's the pump. Disconnect the active going to that for the time being. And yeah, we've got green LED, much brighter, yellow LED. So if I turn this on now, you can see the red, green and yellow LEDs are running. Red's doing nothing. That's with those couple of capacitors in there, and you can hear that relay, actually see it. Little metal piece here move and click off again. So if your unit's clicking like that, then and it still doesn't run, that's something to do with the pump, but I've actually got this one disconnected because I don't want it to run. So that's what it is. It's the actual 1 microfarad capacitor there. This, but we should get the focus. Oh, it's alright for this for the moment anyway. This DNA thing, probably some made in China junk. Doesn't say anything much about it. Maybe the DNA is the brand. But yeah, that's obviously failed over time. And let's see what actual voltage now we have on this electrolytic capacitor in here. So at least I'll know what it's meant to run on. Yeah, so we now got 19 and a bit volts, so more like 20 volts. Possibly those capacitors are a little low, so maybe with a full 1 microfarad you get the full 20 volts. But yeah, interesting that LED. And so yeah, that'll be 20 volts going across that relay, which is plenty to run a 24 volt coil. And now this with no magnets near it. This will be the next interesting test with no magnets near it. guess we'll find out how these reed switches work. So I've got both LEDs on motor running with that down. So I wonder what will happen if we flick that up and hold it up. If that magnet's disabled. Why can't I get that in there? Still got it both running. So that's interesting. And if we leave that running, that might be where the fault mode comes in. If we poke this one in, this should tell it to turn off, which it doesn't. That's interesting with that out. Here's something going ting. But that doesn't actually seem to stop it. Maybe it needs to come in further. Interesting. So with both magnets off. All we get is it running all the time now. So that's an interesting one. The only way that thing's going to drop back. Let's see. That's closed. That's open. So that's running. If both of those suddenly, doesn't make any difference. Oh. Okay, with that down and this in, we get the red fault light. Oh, and it's turned off at least now. Oh, that's interesting. We get pump run and red fault light. Now the pump's still running, and now it's turned off. So the pump's sitting there, power on, nothing happening. That's closed. This slowly loses pressure. This magnet comes in. And I guess what it's expecting is that to immediately lift up, maybe. Yeah, with the fault light on it then turns off. So the pump runs. Test button works, but you can see the lights are back. Got failure mode at the moment, which again is due to no water, so probably if we, I wonder what happens if we manage to tip that upside down so that piece moves. Yeah, that gets the failure light to drop out, so obviously if there's water in there, that's either a float, don't think it's a float though, or it's just the pressure of the water keeps that. Well, as soon as the pump starts, we'll move that up. As soon as I push, well, I can do it. So that's down. Push it up in the failure mode, it should turn off. It doesn't. There it goes. So after a while of failure, I guess it realises it can't prime itself or can't find any water or whatever, so it just turns off and lights up the failure light. And then I'll give it a quick run. If we drop that out, it's none the wiser that it's got no water in there. So that was the part. So low voltage, I should have about 19 volts in there. This one was down to 5 volts, so that explains why it didn't want to work in a couple of these capacitors, a couple of 4.47s, which is comes up equivalent to 1 microfarad in series, in parallel, sorry. Of course they halve if they're in series and double if, or not double, if it's the same value, they'll double or halve, or if they're different values you'll get something where in between. But that got it going again, so it looks like that's the main problem with these things. When they sort of go, if they've got a dim light, barely see the power on, so they probably get gradually worse over time. Not sure if they suddenly fail or whether they just gradually, you probably find the lights get dimmer and the thing gets less reliable. I know the pump we got here is sometimes unreliable when it hasn't been used for a while, so it makes me wonder if it's not something like that in it. But anyway, thanks for watching.